Forces in Newton's law.
Now I understand how to do this. The act is so controlled, Marker. Can I not?
All right.
I finally understand all but I understand now. Yeah.
So the second part of our unit is about Newton's laws and sort of the basics of physics. So let's talk about some general terms first of all. So in physics, we talk often about forces. The forces being applied to an object. What is a force? How could you define it? Bella?
The amount of gravity being put on an object?
Well, gravity does exert a force, but there's lots of other forces besides gravity. What else? Bella?
Something that makes something happen.
Well, I could exert a force on this desk. I'm still exerting a force, but nothing's happening.
What? Why are you moving a force? What force?
The force of me.
Oh. Yeah, it's moving very slowly.
But the other force is acting against it.
True.
Like an object or thing, an object pushing its own weight against another object.
You're getting closer. So our definition is going to be a force is a lift, a push, or a pull on an object. We also have two sort of special forces that we talk about, friction and gravity.
Oh, friction creates
What is friction?
when you
Raise your hand and tell me what friction is. Megan?
It is when you rub two things together, creating heat.
Okay, it's when it's a force that resists the movement of an object between two surfaces sort of rubbing against each other. And yes, friction causes heat. Like if you saw the original Karate Kid, Mr. Miyagi rubs his hands together and heals Daniel.
What?
Busted up knee. The real Karate Kid, not the
good
bad, yeah,
The good one.
Jaden Smith one or the.
that was
They are coming out with a Cobra Kai movie.
Yeah,
Wait,
it's
hold
reduced
on.
red.
In Karate
They're
Kid, did they
reduced
go to
red.
China?
Okay.
I don't know why.
In Karate Kid 2, they go to China.
Why China?
That's where Mr. Miyagi was
There's
from.
something against China. And
Yeah, he has something.
So,
That's not where karate is from. It's from Japan.
anyway, friction is a force that resists movement. So, your shoes, the force between your shoes and the ground have a fair amount of friction, right? That's why you can't slide very well in shoes. But if you were to take off your shoes, you can slide more in your socks than you could.
But it would be painful with
And where could you slide even better?
Ice.
On ice, because it has less friction. So friction resists movement. Different surfaces exert different amounts of friction, and they resist movement in different amounts. Another important special force is gravity. Gravity is, how could you define gravity? Willa?
Like a force pulling objects towards the negative.
Okay, that's pretty good. Gravity is an attractive force between two objects. Not just planets, actually. Gravity is a force between any two objects. We'll talk more about that.
Wait, so there's a force between
Yes. Yep. All objects have a force of gravity between each other.
Yeah, like us and her.
And,
Do you
all
have
right,
a stronger force when you don't like somebody?
a repulsive force.
Repulsive.
All right, so we're going to talk about Newton's laws. So Isaac Newton is one of the most famous scientists. He actually came up with lots of different things besides physical laws. He was a mathematician as well. He did a lot of important work, and we'll learn a little bit about that when we watch the short biography of him sometime. So there are going to be three of Newton's laws, which apply to objects moving or not moving, and you're going to have to learn them and be able to write them out. They're really not too difficult. But Newton's first law is so often called the law of inertia. Does anyone have any clue what inertia is?
Nursing.
Annabelle?
Like physical acceleration speed.
Not quite. Willa?
When objects keep doing what they're doing.
So it's inertia is, yes, the property in which an object generally will continue doing whatever it has been doing. So the way we sort of say that in the words of Newton's law, an object at rest will stay at rest. An object in motion will stay in motion with the same speed, the same direction, unless there's an outside force acting upon it.
Is that like guard?
So, for example, my keys right here, okay, are at rest, and their tendency is to stay at rest. The only way they're going to move is if what happens? There's an unbalanced force acting upon them, like me pulling them up. Okay. At the same time, if I roll this little cart here. So what does Newton's law say this cart should do?
Keep moving.
Keep moving forever.
Would it if there was no other force?
Would it? Will it now?
No.
No.
So is Newton's first law not in effect?
No, it is.
No, it
Because
is.
the other force is gravity. Yeah,
Other
or
forces.
something.
Wait,
You're the other force.
Is that
Friction,
one?
maybe. I don't know.
So
Yeah.
there is another force working here.
Yeah.
That is the friction between the wheels and the wood and the axle. And so that force is the force that stops this cart from doing what it is doing. If we were in a perfect friction-free universe,
It would keep going.
a small push on this car would keep it going forever. And you sometimes see this in like movies that take place in space, right? A person like Interstellar or something gets pushed away from their spaceship and they're not tethered.
And they keep on going.
They just keep floating forever. There's no air resistance to slow them down. Just move away forever. That's why it takes much less force to move a spaceship in space very far, because there's no air that's resisting its movement. There's no friction.
Has that actually ever happened
No.
to a person that never
No.
got like lost
Nope.
in space?
All right, so inertia is important in lots of different ways. We could demonstrate inertia with like the tablecloth trick. You know, where you have a tablecloth that's set with, and if you just
Oh,
take out the tablecloth or the piece of paper, why does the cup just stay there?
You did it so fast.
So fast. The force.
It has inertia. What is inertia? Its inertia is making it do what?
it's staying.
Stay in the same place.
So it
Okay.
has some.
And the force of me pulling this out was not enough to move it. Okay. Now,
How come in the movies all the glasses go like that when
they're not supposed to. If somebody messes up the trick. Or what if I used
it's just
what if I used
Something little
a sock
like
under it?
Obviously it will.
Yeah.
Would that work if I was using like a sock?
No. Because it's not flat.
What's the difference between a sock and that piece of paper?
It's thicker. It's
No.
thicker. It's got more friction. Yeah.
Yes, there's much more friction. A rougher surface has much more friction, creating a greater force that's opposing that movement, and that would not work as well. Don't try it right now. This is also extremely important in vehicles.
Why do you have a green one?
So if I have a little road here, and let's say if I have Mr. Arcuri sitting in this car, so right now everything's at rest. We'll stay at rest. What happens, so let's say you're driving with your reckless brother,
Oh yeah, that's my brother.
and you're in the car with them at the stoplight, and then for some reason the light turns green, and they accelerate, they hit the gas. How do you feel? What happens to you as a passenger?
You go.
Right, you go flying backwards. Why do you go backwards?
Because then it goes forward
You're not actually going backwards.
You're just going.
You're staying still. What's happening to the car? It's moving forward, pushing you against the back of the seat, so it feels like you're being pushed back. Really, the car is being pushed forward while you stay still.
Wait,
So your brother speeds to the next red light and then slams on the brakes when they get there.
You're staying still.
You collide
No.
forward.
No, you're moving forward.
You're continuing forward. What happens to the car?
Cars.
It stops, and what do? You go
Whoa.
forward. Hopefully, well, so let's say Mr. Arcuri is texting on his phone, not paying attention,
He doesn't wear a seatbelt.
doesn't wear a seatbelt.
Oh,
Sorry, Mr. Arcuri. It's not what I was hoping was going to happen.
Rip monkey.
Cho would have survived.
Yeah, show it.
It's supposed to hit the book and then he's supposed to go.
That's to repair my vehicle.
Steel to survive.
And do like Phillips. So he's still would have survived.
Yeah, show it.
How?
The only people who
You
survived was Mr. Fabio. Wait, so we got two. And Cho.
All right, so let's say
So he's a bird.
this thing is not. Excuse me for a minute.
Spoiler alert, Mr. Fabio dies in Infinity War.
Yeah.
You guys were wondering. Sorry, you shouldn't have listened to me.
All right, so let's say Mr. Arcuri is back in his car.
In your Mercedes.
I hope he doesn't die.
Especially on his birthday. Today's Mr. Arcuri's birthday. Do you guys know
Happy
that?
birthday, Mr. Arcuri.
Hey, he turned 50 today. All right, so if he's not wearing a seatbelt,
He got back from the hospital. Ow.
Oh.
that's what happens when you don't wear your seatbelt. You go flying forward. What does wearing a seatbelt do for you?
Keeps you in
Look at that seat.
What does it actually do? Think about physics.
Keeps you still from falling.
It attaches you to the car, so instead of going flying forward, you push against the seatbelt, which is anchored to the car. So even if Mr. Arcuri does this, he stays in the car. He still goes forward. You can still feel yourself being pushed against the seatbelt, but you're not going to go flying out of the car.
I want to go
All
flying.
right, let's have him take off the
That
seatbelt.
sounds
real quick.
fun.
Vice pretend this.
Do you want?
Peter, yo, I'll go like this.
Oh,
Vertical one
So
side.
he said, "Oh, just crash it that way." And you go.
All right.
Can you go backwards? I'll catch myself.
What?
Like backwards. See what happens?
Yeah. Go back.
If he's facing backwards,
Yeah.
he's chatting with somebody in the back seat.
No, like he meant wait, like he didn't park it. He didn't put on park. It was just really back.
This reminds me of Final Destination. Mr. Arcuri is a reckless driver.
He is. All right. Any questions about Newton's first law?
That was a good one.
That was the best.
Yeah, I understand. Thank you, Mr. Durock.
No problem. No problem.
Wait, so when if I was sitting and then wait, if there was no seats and no seatbelts in your car, you were just standing.
Yeah.
Say you had everything removed from your car, seatbelts and
Yeah.
so you would have
You're standing on a vehicle like this.
no, you're
Oh.
yeah, and you're inside the vehicle though. You're inside.
You're
the
gonna
vehicle.
fall.
So once you start moving, are you just gonna fly back?
What happens?
So like you're in a car.
Yeah, you're in the passenger seat of a car.
Yes.
And so there's no seats, no seatbelts. So you're standing up in a car. And then the car starts moving.
That's
You
what
go
happened.
flying.
Yeah, like imagine that's
Like
this
you would
exact
hit the
situation. If
back.
I'm standing on this little rolly cart and somebody pushes only the cart forward,
Oh, you'll fall.
what's going to happen to me?
You're
I'm
gonna
going flying backwards, right?
Well, really.
No. Or if I'm going forward
Show it
and
stand.
somebody sticks their foot out and stops it, what's going to happen to me? I'm going to go flying forward, right? Like if you're on your skateboard, you hit a rock, and your skateboard stops, you continue forward. It's not that cool if it's you, but that's
Show
good.
it. Show it. Show it.
Show it.
All right.
How would he survive?
I guess we'll watch the video tomorrow. So
How?
we spent too much.
Okay, Amber, you're just jealous. You're just jealous.
Well, is it made of steel?
What?
How is it made of steel?
Show what?
I don't know. Oh, I asked. How did Johnny
When I
ask
put
this?
myself go like this, the car's
Yeah, but I forget why she asked about Johnny Atkinson.
Oh
Why did he wear a pot on his head? That's so weird.
Because it's comfortable and protects
I don't think it's very comfortable, Willa.
A pot?